Hi there, and welcome to the lesson on linear inequalities. So the purpose of this video is to take a look at how to solve algebraic linear inequalities and how to use graphing as a way of solving linear inequalities. Now, first off, looking at what an inequality is, an algebraic inequality is one where you replace the equal sign that's in the equation with either a less than equal to, greater than equal to, less than, or greater than symbol. So, for example, if you had the equation 4x minus 3 equals negative 11, well, the inequality, if you choose one of those symbols, would become something like this. Now, this particular section is all about linear inequalities, and so just like a linear equation, a linear inequality has a degree of 1. So the highest exponent you'll find in a term is 1. So how do you solve a linear inequality? Well, we're going to take a look at an algebraic way of solving them first. So there's a couple of examples here at the bottom. I'm just going to scroll so that it's closer to the top. So we're going to solve these kind of like we would solve a linear inequation, but there is one caveat that we need to be careful of, and that is when you multiply or divide by a negative value, it's going to affect that symbol, that inequality symbol. Solving the first inequality then, what we're going to do is collect the like terms together, and that is we're going to move the minus 3 to the right side of that inequality. So we would have 4x is greater than, and when we move the minus 3 to the right side, this becomes negative 11 plus 3, and negative 11 plus 3 is negative 8. Next step is to divide both sides by that 4, so we get x is greater than negative 2. Now, one way to check to see if this solution set is correct is to choose a value that satisfies this inequality, and if it satisfies the original inequality, then you've got the right answer. So, for instance, a value that is greater than negative 2 is something like 0. So if I come back to the original and go 4 times 0 minus 3, the answer to this is negative 3. Is that greater than negative 11? And the answer is certainly yes, it is. So therefore, our solution set is correct. Now in number 2, in order to solve this inequality, we need to use the distributive property first to move the 3 through those brackets and to move the 4 through those brackets. So 3 times the first set of brackets gives us 9 minus 3n greater than equal to, and then on the right side of the inequality we have 4 times n and 4 times 3. Next step is we'll collect the n's to the left side and the 9 to the right side. So we have negative 3n minus 4n gives us a negative 7n greater than equal to, and then we have minus 12 minus 9 gives us minus 21. And then when we divide both sides by a negative 7, hold on, we're dividing by a negative 7. So if we divide by a negative 7, it means that we need to be very cautious here, change the direction of that symbol. So instead of the greater than, we're going to have a less than. And then when we divide negative 21 by negative 7, we get a positive 3. Of course, we can always test our solution set by choosing a value that's less than 3, like 0. When I plug 0 into my n here and in here, I should prove that the left side is greater than the right side. So when I plug 0 in here, 3 minus 0 is 3. 3 times 3 is 9. Okay, and then when I plug in 0 here, minus 3 is negative 3 times 4 is negative 12. And sure enough, 9 is greater than negative 12. So therefore, our solution set is accurate. Now, taking a look at how to solve a linear inequality by graphing, compare the parts of the inequality with the parts that are in the graph. So for instance, the 2x plus 3 is given by this slanted line, and the negative 1 is given by that horizontal line. So in the inequality, they're saying when is this part of the inequality, the 2x plus 3, less than or below the horizontal line? If I highlight this portion of the graph, that part of the graph is below the horizontal line. Therefore, this red arrow represents the solution set. to this inequality? Well, notice that this inequality is in terms of x, so our solution set should be relative to x. According to this arrow, the x value of this endpoint is -2. And since that arrow goes to the left, notice I'm talking about in the x direction, not talking about the y direction as in down. Going to the left means that x would have to be less than -2. Could it equal to -2? The answer is no, because this inequality does not have an equal sign in it. So my final solution set to this inequality would be that x must be less than -2. Looking at example 4, I'm comparing these two lines. One is this line greater than or above the other line. So now taking a look at the two lines and their respective equations, we're looking for when this line, given by x minus 3 on the left side of that inequality, is greater than this other line. So when I draw this portion, when I highlight that portion of my graph, notice how that red line is above this other line given by the right side of that inequality. So the starting point for this red line is at 2, and it's going to the right. My solution set will say x greater than equal to 2. Finally, looking at how to solve a double inequality, notice how this inequality is written twice. We're going to express the solution set not only in interval notation, but also in absolute value notation, which is a topic that you would have learned in a previous lesson. In order to solve a double inequality, we're basically going to solve two single inequalities at the same time. So what we do to the left side of the inequality, we'll do to the right side of the inequality. So, concentrating on the middle portion, I want to get x by itself. So my first step to do that would be to get rid of the 6. In the next step, we want to, once again, isolate x is our goal, so we're going to divide by -2. We're dividing by -2, which means we need to change the direction of all the symbols. So 5 is greater than some value of x, which is greater than 2. Or I can read this backwards. 2 is less than x, which is less than 5. Since there is no equal sign in our inequality, using round brackets to represent the solution set. If any of those two was equal to, then we would use a square bracket. For example, if it was equal to 2, then we would use a square bracket on the left side. So within the parentheses or the brackets, we would put the lower boundary first, which is 2, and the upper boundary second, which is 5, separated by a comma. So this is your interval notation for this standard solution set from 2 to 5. So now how do we express this solution set in absolute value notation? It's just another way of expressing a solution set. So to start off, what we need to do is determine the center of this interval notation, and then determine how far each of these endpoints is from that center. So to find the center point, we'll find the average of 2 and 5, so 2 plus 5, and then divide by 2. That gives us 3.5. So, and that's a positive 3.5. Now, to introduce the absolute value symbols, recall that they're the vertical bars. So we'll indicate vertical bars, and in between the bars, we're going to put an x minus 3.5. Now, the reason why it's a minus 3.5, if you think back to transformations, a shift to the right 3.5, because this is a positive 3.5, a shift to the right would be expressed as x minus 3.5 inside the function. So inside the absolute value symbols, we would have an x minus 3.5. Next, we're going to use the less than symbol, and the reason for that is because we have an interval that is between 2 and 5, so we'll use the less than symbol. If we had a solution set that was beyond 2 and beyond 5, then we would use the greater than symbol. And then the next step is to find out how far is this midpoint, 3.5, from each endpoint. So we can just pick one of them. We'll pick the right end, which is 5. So how far is 5 from 3.5? And when you do that math, you get 1.5. And that's the value that we put on the right side of that inequality. So now if we choose a value that's within this interval, like 3, when you plug it into the absolute value notation, you'll be able to prove that the answer is less than 1.5. And so that completes the different way of expressing the solution set to this double inequality. If you found this video to be useful and you like the style of teaching, then please subscribe so that you can view some more videos. And if you like the video, then please press the like button. Thank you, and see you next time.